Okay. Um, October, November 2018, paper 4, variant 1. Question 1. A train of mass 5.6 times 10 to the power of 5 kilograms is at rest. At time t equals 0 seconds, a resultant force acts on the train and starts to accelerate forwards. This is a distance time graph. This is a distance time graph. It's not a speed time graph. Distance time graph for the first 120 seconds. Use the figure 1.1 to determine the average speed of the train during the 120 seconds. How can I find the average speed? Average speed equals what? Total distance over total time. What was the total distance traveled by the train? Total distance would be the maximum distance reached, which was not 5,000. It's less than 5,000. This is 4,800. And the total time was 120 seconds. So average speed equals total distance over total time, 4,800 over 120, which is 40 meters per second. Okay, 40 meters per second. Okay. Can I find the speed of the train at 100 seconds? Yes, I can. At 100 seconds, the distance reached by the train was 3,600. 2, 3, 4. Yes, 3,600. So most of you might say 3,600 divided by 100, which would be definitely wrong. Okay, you cannot say 3,600, Hannah. This is 3,600. You cannot say 3,600 divided by 100. That would be definitely wrong. You need to find the slope. You need to find the slope. How can I find the slope? y2 minus y1 over x2 minus x1. At this point, you had y of 3,600 and an x of 100. Can I take the other point to be 4,800? Yes, you can. This is a straight line. Okay, you can take this point, you can take مثلا this point, whatever. Okay, but you need to take 2 points on this line to find the slope. يبقى y2 minus y1 over x2 minus x1 4,800 minus 3,600 over 120 minus 100. Okay, this would give you a slope of this would give find an answer of 1,200 over 20, which is 60 meters per second. 60 meters per second. Okay? Easy. Describe how the acceleration of the train at time 100 seconds differs from the acceleration at time 20 seconds. At time 100 and at time 20. Let's check out the graph. At time 20, the slope was increasing. At time 20, the slope was increasing. At time 100, the slope was constant. You had a constant slope. صح؟ There's a huge difference. Increasing slope means that the speed was increasing. Constant slope meaning that the speed was constant. Therefore, we can say that at time 20 there was an acceleration. It was accelerating. Okay, there was an acceleration other than zero, above zero. It was greater than zero. The speed was increasing. But at time 100, the acceleration was zero. Why was it zero? Because it was moving at a constant speed. So at time 20, okay, at 20 seconds, the speed, okay, the speed was increasing. يعني we had a positive acceleration, okay, acceleration. But at time 100 seconds, the speed was constant, okay, constant speed, and therefore the acceleration was zero. Okay, there's a huge difference. This is a distance time graph, not a speed time graph. The initial acceleration of the train is 0.75 meters per second squared. Can I find the resultant force? Yes, I can find the resultant force. F equals ma. F equals ma, in which the mass was the initial mass هنا 5.6 times 10 to the power of 5. 5.6 times 10 to the power of 5 times the acceleration, which is 0.75. This would give me a resultant force of 4.2 times 10 to the power of 5. 4.2 10 to the power of 5 newtons. At time 20, at time 120, the train begins to decelerate. What does it mean? Deceleration means that the speed is decreasing. It is slowing down. Negative acceleration. Speed. Speed decreases. Slowing down. Negative acceleration. Whatever. Okay? Hmm. Figure 2.1 shows a uniform plank AB of length 2 meters suspended between ropes X and Y. State in terms of P the moment of force P about B. P is a force, and I need to find the moment about B, meaning that B is the pivot. B is the pivot. Whenever I say about a certain point, then this point is the pivot. Moment equals force times perpendicular distance. The force is P and the distance is 1.5. Distance هنا 1.5. So P times 1.5. That's it. Calculate the moment of W about B. W about B. Distance, force times perpendicular distance. Moment equals force times perpendicular. The force 210 newtons, and the distance, it should be 1 meter. Why? Because the total length of AB is 2 meters. So, total length is 2 meters. The weight acts at the center of mass, which is at 1 meter. Okay, so distance is 1 meter, and the moment would be 210. Again, do not forget the unit, Newton dot meter. So, Newton dot meter. Force P. Can I find the force P? Yes, I can find the force P. How can I find the force P? Clockwise moment equals anti-clockwise moment. P is exerting a clockwise moment. And W is exerting an anti-clockwise moment. Clockwise moment, it's at rest. It's in equilibrium. Okay, so clockwise equals anti-clockwise. The anti-clockwise moment was 210, and the clockwise moment, which is P times 1.5, divided by 1.5. So force P would be 140. 140 newtons. 140 newtons. Can I find force Q? Yes, I can find force Q by using the other statement, which is upward forces are equal to the downward forces. Upward forces, what are the upward forces? Upward forces are equal to the downward forces. We have two upward forces, which are P and Q, and we only have one downward force, which is W. 140 plus Q equals 210 minus 140. This would give you a force of 70 newtons. صح؟ 70 newtons. يلا. It's not that difficult. State what is meant by the principle of conservation of energy. Principle of conservation of energy. Energy is neither created nor destroyed. Neither created nor destroyed. Either created nor destroyed. It can only change. Yeah, it can only change from one form to another. Can only change from one form to another. Okay. Figure 3.1 shows a girl throwing a heavy ball. State the energy changes that take place from when the girl begins to exert a force on the ball until the ball hits the ground and stops moving. Energy changes. Girl is moving, is applying a force on the ball. The ball will rise up and then it will fall back down to the ground. Initially, initially the girl had what type of energy stored inside? Okay, inside our bodies we have chemical energy stored. So chemical energy is transferred to kinetic energy as you move the ball. Chemical energy is transferred to kinetic energy as the ball moves. And then you can say it could be changed to gravitational potential energy as it rises up. Okay, you can say, yeah, let's write down chemical energy to kinetic energy and gravitational potential energy. Okay, as it rises up. And then you can say, okay, um, chemical energy to gravitation as it rises up, and then you can say uh, chemical energy, sorry, kinetic energy, or you can say gravitational potential energy to kinetic energy, then gravitational potential energy to kinetic energy as it falls down, as it falls down. And then when it hits the ground, when it hits the ground, what happens? When it hits the ground, you can say that the energy is transferred as heat energy or sound energy because it's hitting the ground. Okay. And then kinetic energy to heat energy as it hits the ground. Okay. Hmm. Yeah. Okay. يلا بينا. Next question. The mass of the ball is 4 kilograms. The girl exerts a force on the ball for 0.6 seconds. The speed of the ball increases from 0 to 12 meters before it leaves the girl's hand. Can you find the momentum of the ball leaving the girl's hand? Can I find the momentum? Yes, I can find the momentum. Momentum equals mass times velocity. Momentum equals mass times velocity. Momentum equals P equals mv. There was a question: kinetic energy in the girl or in the ball? In the ball, in the ball, not in the girl. The girl had chemical energy. As she was moving the ball, as the ball moves, the ball gains kinetic energy. Okay, P equals mv. Okay, P equals mv. So 12 times 4. Okay, 12 times 4. طيب final velocity. Okay, mass times 12, which is 48. Again, do not forget the unit, kilogram dot meters per second. The average resultant force exerted on the ball, average resultant force, you can find it either using force equals ma or using the impulse equation. What's the impulse equation? Force times time equals mv minus mu. And since the ball was initially at rest, so you can cancel out mu, and you can find the force. So force equals mv over t, which is 48 mv, 4 times 12, 48 over t, which is 0.6. 0.6. So the total force would be 80 newtons. Okay, 80 newtons. Yeah, not that difficult. Alhamdulillah. Okay, figure 4.1 shows a cylinder. Calculate the density of the liquid. The depth of the liquid is 10 centimeters. The radius of the cylinder is 3 centimeters. The weight inside the cylinder is 2.5 newtons. Can I find the density? Yes, I can find the density. How can I find density? Density equals mass over volume. Mass over volume, you can find it either way. Yeah. You can find the mass in kilograms and the volume in meters cubed, or or you can find the mass in grams and the volume in I said grams and centimeters cubed. So either you find kilograms and meters cubed or grams and centimeters cubed. Okay, either. Don't find, for example, don't find the mass in kilograms and the volume in centimeters cubed. No, that would be incorrect. Let me solve it using what? Let's use the kilograms. Let's find the mass first of all. The mass, we have the weight. To find the mass, mass would be equal to weight over g, which is 2.5 over 9.8. 2.5 over 9.8 would be around 0.25 or 0.26. Yeah. 2.5 divided by 9.8 is 0.255, which is 0.26. 0.26 kilograms. So this is the mass. Can I find the volume? Yes, I can find the volume. What is the volume? Volume equals, this is a cylinder, so it's pi r squared times height. But you need to change the centimeters to meters. 10 centimeters is 0.1 meters. Radius 3 centimeters, so it's 0.03 meters. Pi r squared, yeah, volume equals pi r squared times height, which is pi times the radius 0.03 squared times the height, which is 0.1. It would be a very small number, which is okay, which is definitely okay. So pi times r squared, 0.03 squared times the height, which is 0.1. 2.83 times 10 to the negative 4. 2.83 times 10 to the negative 4 meters cubed. Meters cubed. Can I find the density? Yes. Mass over volume. 0.26 over 2.83 times 10 to the negative 4 times 10 to the negative 4, not negative 3, times 10 to the negative 4. Yeah. 0.26 divided by this number, it would be around 920. Okay, 920 kilograms per meter cubed. Okay. Roughly, yes. Roughly 920 kilograms per meter cubed. If your mass was 0.25, if your mass was 0.25, then you would have had a different answer, a slightly different answer. Okay, if your volume was 2.8 instead of 2.83, then you would have had a different answer as well. So these small differences could change your final answer. Okay, your final answer could be around 880, 890, around 900. Okay, so these slight differences in your calculations could give you a final answer, a different final answer. So 920 would be okay, 902 would be okay. Yeah, it doesn't actually matter that much in this question. Okay, because you have very small numbers and you have a lot of approximations in this question. B is cancelled. B is cancelled. This is a manometer. It has been removed. Okay, it has been removed from your syllabus. هنا as well I and triple I, okay, have been removed. So we can just cancel out the remainder of the question and move on to the next question. Thermocouple, this whole question has been cancelled. So you're very lucky today. Question 5 is all cancelled. Okay, you will not solve anything in question 5. This is your lucky day, I guess. Okay, moving on. Question 6. Three factors that determine the rate of evaporation of water. Rate of evaporation of water. We have three factors, which are surface area. Yes, temperature. Okay. What about the wind? Okay, that's it. Three factors. Surface area. Temperature. Wind speed. A person climbs out of a swimming pool and stands in the open air. Explain why evaporation from the water surface, okay, of the water from the surface of the person's body causes the person to feel cold. We need to state What happens in evaporation? What happens during evaporation? Most energetic molecules escape from the surface. Most energetic molecules escape from the surface, leaving behind the least energetic molecules. Energetic molecules. Decreasing the average temperature. Average temperature causing a cooling effect. Causing a cooling effect. Okay, not bad. Hmm. يلا. Hmm. Next question. A laser produces a beam of monochromatic light. State what is meant by monochromatic. What does monochromatic mean? والله monochromatic means one frequency, one wavelength, one color. Monochromatic means one frequency or wavelength or color. I have a wave which was incident on a glass block. This wave undergoes reflection and refraction. Reflection and refraction. 3 marks and 3 marks. First of all, we need to reflect the wave and then we need to refract the wave. Reflection would be quite easy. Reflection as the wave moves, okay? You need to continue this as a straight line, and then at this point we can draw a normal line. Okay, draw the normal line at this point. And then what should you do? You need to measure the angle of incidence. Measure this angle of incidence. And then what do? You draw 3 reflected waves. Okay, 3 reflected waves in the air. Measure the angle of incidence, draw the reflected angle of reflection, which would be the same. Okay, they have to all be of equal wavelengths. Okay, what do I mean? First of all, you need to draw the reflected ray with the same angle, which would uh, go somewhat like this, and draw the arrow. Okay, angle of incidence equals the angle of reflection. I equals R. I equals R. First of all. Second of all, you need to draw at least 3 wavefronts. 3 wavefronts which are incident on this line, which are actually perpendicular on this direction. They have to be perpendicular. Yalla, draw them perpendicular this way. Okay, with equal wavelengths. And these wavelengths have to be equal to the initial uh, wavelengths, meaning that you have to measure the wavelength. You need to measure this wavelength, and you need to make sure that this wavelength is equal to the initial wavelength. The wavelength does not change while going through, while reflecting. But while refracting, when the light refracts as it passes from the air to the glass, what happens? So light refracts. It bends. It bends actually towards the normal. It bends towards the normal. The angle decreases. The angle of refraction is less than the angle of incidence. Angle of refraction is less than the angle of incidence. Hmm. Let's draw them. Let's draw them. Let's change the color. Okay, a refracted wave with an angle much less. Okay, much less. For example, the wave would move somewhat like this. Okay, with an angle with a wavefront less than the initial wavefront. Wavefront initial Wavelength is less than the initial wavelength. Definitely, you're using your ruler. Okay, do not use your, do not draw freehand. This is not a freehand. This is not a simple diagram to draw. You need to use your ruler. You need to be very accurate while drawing these lines. You need to make sure that these lines are perpendicular to the direction of motion. This is the direction of motion. You need to make sure that these lines are perpendicular. Okay, and these wave lengths are equal. They're smaller than the initial wavelength, but they are equal. They have to be equal. Definitely, they have to be straight line. You cannot have these. Um, you cannot have any lines that are not straight. Yeah. Anyway, so these are the reflected waves and the refracted waves. A transverse wave is produced on a long horizontal rope. The rope is much longer than the wavelength of the wave. In the space below, sketch a diagram to show the appearance of a rope as the wave passes along it. Label two important features of the wave. Simply, we need to draw a transverse wave. We need to draw a transverse wave. How can I draw a transverse wave? Yeah. So I drew two waves, so two waves of a transverse wave. I need to label some important points. For example, this is the wavelength. This is the wavelength. Let me actually write a wavelength. Wavelength. This is a trough. This is a trough. This is a crest. We can draw the amplitude. So this distance is called the amplitude. Okay, ماشي. Hmm, not bad, huh? Explain what is meant by a longitudinal wave. That's easy. يلا, a longitudinal wave is a wave that moves left and right. It vibrates left and right, parallel to the energy motion. It consists of compressions and rarefactions. يلا, it vibrates left and right, parallel to the energy motion. Hmm. Energy motion. It consists of of compressions and rarefactions. يعني compressions and rarefactions. Hmm. حلو. The frequency of a wave is 800 hertz. The speed is 330 meters per second. State a typical value for the speed of sound in liquid. Speed of sound in liquid. Typical value would be around 1500 meters per second. Okay, 1500. Use your value from BI to calculate the wavelength of the sound wave in the ocean. Can I find the wavelength? Yes. Speed over frequency. 1500 over 800, which should be around 1.875, I guess. 1500 divided by 800. 1.875, yes. 1.875 meters. Hmm. Okay. Hmm. Moving on to the next question. Question 9 shows a symbol for a 12-volt battery. Two lamps are connected in parallel with the battery. Using the correct symbols, complete the diagram. All you need to do is draw two lamps. Can I draw two lamps? Okay. حاضر. One lamp. Okay. And another lamp. Probably the easiest mark you'll ever get in paper 4. This is not a paper 6 question. This should be a paper 6 question, but this is a paper 4 question. That's why this is the easiest mark you will get in paper 4. One of the lamps has a resistance of 6 ohms. Calculate for this lamp the current. Can I find the current in this lamp? 6 ohms, yes. I equals, يلا, I equals V over R. So 12 over 6, which is 2 amperes. That's it. Yes, that's it. Can I find the power? Yes, I can find the power. Power equals VI. Power equals VI. The voltage of this lamp is 12 volts and the current to 24 watts. Okay, seems like this exam is a bit easy. The power of the other lamp is 36 watts. Calculate the total energy delivered to this lamp in 20 hours. Calculate the total energy delivered to this lamp in 20 hours. Well, energy equals power times time. Energy equals power times time. What is the power? 36 watts. The time is 20 hours. But you need to change the time to seconds. So times 60 times 60. And the total energy would be around 2.6 times 10 to the power of 6. 2.6 times 10 to the power of 6 joules. Uh, extra easy and it's super easy. 3 marks. I don't know why. Maybe this exam is that easy. Hmm. Yeah, question 10. State the name of the metal from which the core is made. The core has to be made of iron. Cannot use steel. It has to be made of iron. The primary coil of the transformer uh, is connected to the output voltage of an AC generator which supplies an alternating current. Explain why there is a voltage between the two terminals of the secondary coil. Basically, we need to state the operation of this transformer. State the operation of the transformer. What happens? How does this transformer operate? Well, we have some points we need to talk about. First of all, the alternating current in the alternating current in the primary coil. Okay, it produces or it generates what produces an alternating magnetic field. Okay, produces an alternating magnetic field, which cuts, which you have to say that it cuts, which cuts the secondary coil, hmm, producing an alternating induced EMF, producing an alternating induced EMF in the coil. Hmm. Okay. Yeah, there you have 560 turns on the primary coil, 910 turns on the secondary coil. The voltage between the two terminals of the secondary coil is 78 volts. Can I find the generator voltage, or basically the input voltage, which was VP? We have one equation. One equation. What is it? VP over VS equals NP over NS. Yeah. VP, we need to find VP. VS is 78. NP, 560 turns on the primary, 560. NS, 910. Cross multiply, 78 times 560 over 910. So the generator voltage would be 48. 48 volts. Transformers are used to increase the voltage when the electrical energy is transmitted in cables across long distances. Explain why the power losses in the cables are lower when the voltage is high. When the voltage increases, what happens to current? What happens to the current? والله current decreases. Current, يلا. Current decreases. But as the current decreases, what happens to the power lost? Power lost decreases because the heat loss decreases. Okay, heat loss decreases يلا الهيت lost decreases, الباور lost also decreases, and you can write down the equation for the power. Okay, power equals I squared times R, not VI. You can write this equation I squared times R. Why? Because the current squared. When you decrease the current, then the power lost would decrease significantly. Okay, it would decrease significantly. Okay, I squared times R. Current decreases, power lost decreases, heat loss decreases. Power equals I squared times R. Okay. Hmm. Question 11 shows data about 9 elements. We have 9 elements. Carbon 14 is a radioactive isotope. It decays by emitting beta particles. Use any data you need from figure 11.1 to write down the nuclide equation for this decay. Carbon will decay by producing beta and another element. Okay, let's write it down. Carbon 14, which is C, 14, and the carbon has how many protons? It has 6 protons. So 14 and 6. Okay, it decays. It produces what? Beta, which is 0 and -1, plus something else. This something else would have 14 and what? And 7. It would increase. The number of protons increases when you produce a beta particle. When you produce a beta particle, the number of protons increases by 1. So 7 meaning that this is a nitrogen element. Okay? Nitrogen element. Okay. Hmm. Okay. A radioactive sample is placed close to a detector. The radioactive isotope in the sample has a long half-life. Okay. The detector records a count rate of 597 counts per minute. This is the count rate detected. When you add a sheet of paper, and you add a sheet of aluminum, you add a sheet of thin lead, the count rate changes. Do you have alpha, beta, or gamma? I don't know. Let's see. First of all, do you have any alpha particles? It was 597 and it became 602. So, do you have any alpha particles? No. If you had any alpha particles, the number should have decreased. It now increased. Is this a faulty reading? No, it's not a faulty reading. It's because of the background radiation. If you remember, we had some background radiation, so no alpha particles. Okay, no alpha particles. No alpha. Why no alpha particles? Because the number didn't decrease. Number, our reading, okay, reading almost stayed the same. Reading didn't decrease. But are there any beta particles when you add the sheet of aluminum? Okay, when you add the thick sheet of aluminum, should the reading increase or decrease? It should decrease if you had any beta. Do you have any beta? No, you don't have any beta, so no beta. Yell, no beta. Why? Because the reading also didn't decrease. صح? The reading didn't decrease. It almost remained the same. صح? Do you have any gamma? Yes, you do have some gamma. Okay. Um, why? Because the number decreased. Okay. Okay. So yes, some gamma. Why? Number decreased. Our reading decreased only with the lead. Okay. Reading decreased only with the lead. يبقى beta should be stopped by this sheet of aluminum. Alpha should be stopped by the sheet of paper. And when the number did not change, alpha, paper, and aluminum. Okay, they did not change the number, they did not change the reading. Therefore, we don't have any alpha or beta particles. We only have gamma rays. Why? Because gamma rays were kind of prevented by this lead um, lead sheet. Okay. Okay.